Name of the chapter is temperature. First, we will define the temperature. It is degree of hotness or coldness. So the degree of the hotness or the coldness is called temperature. Due to temperature difference, heat flows. So heat flows from high temperature to low temperature. But when two objects are in contact, and are at same temperature, mean temperature difference of the temperature is 0, then no flow of heat energy between them, and this situation is called thermal equilibrium. So the heat flows from high temperature to the low temperature, but when both objects are at the same temperature, temperature difference 0, no heat flows from one object to the other. This is called thermal equilibrium. For the thermal equilibrium, both objects must be at same temperature. Next, triple point. This triple point is also a temperature. It is the temperature at which water exits at its three states, means solid, liquid, and vapor, mean gas together. So this is the temperature at which water exists at its three states together, solid, liquid, and the vapor, is called triple point, and it is 273.15 Kelvin, mean approximately 0 degrees Celsius. So naturally, heat flows from high temperature to low temperature, but when the flow of heat is required from low temperature to high temperature, then work must be done externally. Like in refrigerator, heat is flowing from low temperature to the high temperature. Outside the refrigerator, suppose the temperature is 25 degrees Celsius and inside it is 4 degrees Celsius, and the refrigerator is set its thermal at 3 degree. So the heat is flowing from the 4 degrees Celsius object to the 25 outside. So the work is done, mean the machine is working, the refrigerator is working, and we are paying for it. So naturally, without doing any work, heat flows from high temperature to the low temperature, but the flow of the heat when required from low temperature to the high temperature, then the work must be done externally, and this work must be paid off. Now, temperature is very, very important. Temperature changes some properties of the substance. And these properties are called thermal properties. So any property of the substance which changes with temperature is called thermal property. For example, number one is the length. Yes, material expands on heating, mean with the change of temperature. Number two, the volume. Volume of the liquid, volume of the substance changes with temperature. Number three, pressure changes with temperature. Number four, electric resistance changes with temperature. And number five, voltage or the electromotive force EMF also changes with temperature. So these are the major thermal properties of the substance, mean the property which changes with temperature. Length, volume, pressure, electric resistance, and the EMF are called thermal properties. So all thermometers work on the principle that thermal property of a substance changes with temperature. All thermometer. Now, there are many units, there are many scales for the measurement of temperature. Number one is called Celsius scale to measure the temperature. Number two is thermodynamic scale. This Celsius scale is measured in degrees Celsius, and the thermodynamic scale is measured in Kelvin. The centigrade scale, the Celsius scale, it depends on thermal properties of the substance, length, volume, pressure, electric resistance, and the voltage. So the centigrade, means the Celsius scale, depends on the thermal property of the substance, but this thermodynamic scale does not depend on the thermal property. It depends on the average kinetic energy of molecules in a substance. And we have proved in the previous chapter that the average kinetic energy of a molecule in a substance is 3 by 2 kT, or the total kinetic energy is 3 by 2 nkt, where T temperature in Kelvin, this is the energy. So this Kelvin scale, mean the thermodynamic scale measured in Kelvin, is depending on the average kinetic energy of the molecule in the substance, but the Celsius scale depending on these thermal properties, length, volume, pressure, electric resistance, and this. Now, thermodynamic scale changes linearly with the change of kinetic energy. But the Celsius scale, Celsius degree, centigrade degree temperature changes with length, volume, pressure, electric resistance and voltage non-linearly. So this is another difference. So kinetic energy and the Kelvin temperature are related linearly, and Celsius scale with thermal property, right, related non-linearly. For example, when you will draw the graph between average kinetic energy and the temperature in Kelvin, it is straight line. Similarly, temperature in Kelvin here, average kinetic energy here, it's a straight line, linear. But if the temperature is in degrees Celsius and the resistance of the substance, so it's not a straight line, not passing to the region. So this is the behavior. It's not changing. Yes, it's increasing. When temperature increases, resistance increasing, but it is not 100% linear, not a straight line. So this is the difference between Celsius scale and the Kelvin scale. Now suppose we have liquid in glass thermometer. This is the bulb of the thermometer. It contains some thermometric liquid like pentane, mercury, alcohol. When this bulb is placed inside the melting ice cube at the standard atmospheric pressure, then the level of the liquid is marked as ice point. And the height of the ice point from the bottom is marked as L0. When this bulb is placed inside the steam, mean few millimeter above the surface of the boiling water at standard atmospheric pressure, then this liquid will rise, and suppose this is the level. So this is steam point, and its height is represented from the bottom with L100. Now this thermometer is placed in a cup of the coffee. So the temperature of the coffee is greater than the ice point, but smaller than the steam point. So suppose this thermometer liquid, mercury alcohol, is here for the coffee. This is the level of the liquid in the thermometer for the coffee. So this temperature is required, and suppose its length is L theta, I mean unknown temperature. Why this is L0? Because this is the length height at 0 degrees Celsius. Why this is L100? Because this is the height for the 100. Why this is L theta? Because the unknown temperature. Now, the empirical formula for the Celsius scale is temperature in degrees Celsius is equal to L theta minus L0 divided by L100 minus L0 into 100. So this is the empirical formula for the temperature in Celsius. Very important. So the height of the liquid for the unknown temperature minus height of the ice point divided by height of the steam point minus height of the ice point times 100. So you will get exact value of the temperature without using any calibrated thermometer. Just 2 points are marked, ice point and the steam point. By measuring the length, by measuring the length of the liquid for the unknown temperature, and then by using this formula, we can find the temperature in degrees Celsius. Now, the next, temperature in Kelvin. Either it is temperature in degrees Celsius plus 273.15 is equal to Kelvin. So when 273.15 is added in the degree Celsius, it is converted into thermodynamic temperature scale Kelvin, or we will use the empirical formula for thermodynamic scale. First, measure the temperature of any gas in the gas thermometer, constant volume gas thermometer. Pressure for the triple point mean the temperature at which the water exits in its three states together, and then calculate the pressure for the required temperature P theta. Then the empirical formula for this will be okay. So this is the pressure at the triple point of the liquid in glass thermometer, and this is P theta. This is the pressure at the required temperature. Then the temperature in Kelvin can be written as pressure at the required temperature divided by pressure at the triple point times 273.15. So this is another formula for the temperature in Kelvin. The first one is this, and this is the second one. Okay, now the definition of the 1 Kelvin. 1 Kelvin is actually 1 divided by 273.15 or 273.16 fraction of thermodynamic temperature of the triple point of the water. So this is the definition of 1 Kelvin. So 1 Kelvin is 1 divided by 273.15 fraction of the thermodynamic temperature of the triple point of the water. If the triple point of the water is measured in Kelvin, then its 1 over 273.15 part is called 1 Kelvin. Okay. Now, different types of the thermometers. So first thermometer is the mercury in glass thermometer. What is the principle? When temperature rises, mercury expands and it moves further up the capillary tube. So this is its principle. What is the range in Kelvin? Its range is from 234 to 700 Kelvin. It is portable. This is the only advantage, but the disadvantage is it's not very accurate. It is fragile and not suitable for the temperature of small objects. This is thermometer number 1. Now move to the next, which is called constant volume gas thermometer. So this is the shape. The bulb contains the fixed masses of hydrogen, helium, nitrogen gases. When temperature rises, the pressure of the gas rises, and the larger height difference H is needed in the manometer. This is manometer to keep the gas at the fixed volume. So this manometer is raised, or more liquid is poured into it to keep the volume constant. The open limb of the manometer can be raised to achieve this. The pressure of the gas is equal to rho GH plus atmospheric pressure. So this is called constant volume gas thermometer. And its range is 3 Kelvin to 1750 Kelvin. Towards the advantage, wide range. It is the most accurate thermometer. It is sensitive. It can be used as a standard, means for the calibration of the other thermometer. But the problem is no direct reading. First, we have to measure pressure, and then we have to calculate the temperature. It has slow response, not suitable for the fluctuating, rapidly changing temperature. It is fragile, cumbersome, because many parts are used and not suitable for the temperature of the small objects. This is thermometer number 2. The next one is the platinum thermometer, mean resistance thermometer. And this principle is when the temperature rises, the resistance of the platinum coil rises, the resistance is measured accurately with the circuit which makes use of the balanced potential divider or its ohm meter is calibrated into temperature scale, either degrees Celsius or Kelvin. Usually it is calibrated into the centigrade. So the ohm meter measures the resistance, but the resistance is calibrated, our ohm meter is calibrated into temperature degrees Celsius, and its range is 25 to 1750 Kelvin, not centigrade. It has wide range. Yes, it's also accurate. It's sensitive. It's suitable for the varying temperature, changing temperature. But the problem is no direct reading again, and it has slow response, not suitable for the temperature of the small object. Now the number 4 is thermistor thermometer. When the temperature rises, the resistance of the thermistor falls, a reverse process. One is rising, other is decreasing. When temperature increases, the resistance decreases. The resistance is measured using the circuit, which can indicate the meter calibrated in degree. Mean ohm meter is calibrated in the opposite direction. Suppose this is the ohm meter. For the low temperature is resistance maximum, and for the high temperature resistance decreases, so the temperature will increase in this direction. So it is calibrated in the opposite direction. So if in normal meter, if the 0 degree is at the left, so in this meter, the 0 degree will be at the right. So it has very small range, just 250 to 450 Kelvin, and it can be linked with the other circuit, the computer, limited range, but it is not accurate, just estimated value of the temperature. And the number 5, the last, is thermocouple thermometer. We have done in O level. The circuit contained two junctions of dissimilar metal, different metals. When one junction is hotter than the other, a small thermoelectric EMF is generated. This EMF depends on the temperature difference. Greater the temperature difference, smaller the EMF greater the EMF generated. It is measured using the circuit. Mean voltmeters measure the EMF, and the later voltmeter is calibrated into degrees Celsius to measure the temperature. And it has wide range. Look, from 80 to 1400. It is small, quick response, can be linked to the other circuit like computer. It can be used to measure the temperature of the very small object as well as rapid changing of temperature, but it is less accurate. Its accuracy is very small as compared to the other thermometers.